24 through 28, we're going to solve the trig equation for x in a given interval. Alright, so the first thing I'm going to do is I'm going to add 1 to the right-hand side. So I have 2 sine of x equals 1. Then divide by 2. So I have the sine of x equals 1/2. So now we need to determine all the values for x in this specific interval for which the sine of x equals 1/2. Now, I know when I think about reference angles, I have 1, 2, 3, 1, 2, 3. So sine is the second number. That means I have a reference angle here of 30 degrees or pi over 6. Now, notice that it gives us an interval that's in radians, so I want to provide an answer that's also in radians. So if the sine is positive 1/2 and the reference angle is pi over 6, I also know that sine functions are positive in both quadrants 1 and quadrant 2. That means the sine will also be a positive 1/2 at 5 pi over 6. So the two solutions to this problem would be pi over 6 and 5 pi over 6. Let's take a look at number 25. Now what's different here is look at the given interval. So in this problem, there's a couple different ways we could think about this. We could subtract the cosine to the opposite side, and then many of you will recognize that what this means is where are the values exactly the same but different signs. So they're exactly the same, forget about the signs being different, at a reference angle of pi over 4 or 45 degrees. So they're radical 2 over 2, radical 2 over 2, but they're not the different signs. Same way over down here at 5 pi over 4 or 225 degrees. They're both negative radical 2 over 2 and negative radical 2 over 2 for the cosine and sine. This is named to be different signs. So I know right now that I believe the answer to be true if we only think about it. If we only think about one revolution, I believe the answer would be 3 pi over 4, and down here would be 7 pi over 4. So that's what I believe. But other people may think of this just a little bit differently. They may choose to say, like, I don't know what to do here. So they're going to divide then by the cosine. Divide by the cosine. So the cosines are going to simplify to 1, and then I have negative 1 on the right-hand side, and on the left-hand side, this is going to simplify to the tangent of x. And then you could ask yourself, where's the tangent of x equals negative 1? And in the one revolution, it would also occur in the exact same places. So it's kind of about how do you view it. So now we need to determine for all values of x on the interval from negative infinity to positive, where is the tangent of x equal to negative 1? So our reference angle, like I said, is pi over 4, but we need it to be a negative 1. So in order for that to happen, it needs to occur for them to be different signs, like you see right here. It's going to be in quadrant 2 or quadrant 4, and that's how I was able to achieve the answers of 3 pi over 4 and 7 pi over 4. But those are only two values, and that's only going to be in the interval from 0 to 2 pi. But we're asked to fulfill it from negative infinity to positive infinity. So how could I express those answers? So we have one value of 3 pi over 4, and this would represent for, what's happening here? It's trying to update. Remind me later. For as many revolutions as we want to go around, so n times pi, we would finally get that answer. And same thing here for 7 pi over 4. For as many revolutions as we'd want to go around, we could achieve the exact same answer. And so this is how it expressed the two solutions based on the fact that it says from negative infinity to positive infinity. So whether it's going to just be one revolution or 2 revolutions or 3 revolutions or 4, this would always hit at these 2 points. Let's look at 26. All right, to save a little bit of time here, I started by taking the sine of x and moving it to the right-hand side. Notice that we have this real common, we have this provided common interval of 1 revolution. So starting at 0, including it, going all the way to 2 pi, we're not going to include 2 pi. So when I move sine to the opposite side, I subtracted it over, and then both of these terms contain a sign, so I backed out a sign. Sine of x times tangent of x minus 1, because when you distribute the sine of x, you end up with this negative sine of x above. Alright, now, if this is true, either the left group or the right group equals 0. Kind of like when we say a times b equals 0. What's true? Either a equals 0, b equals 0, or they both equal 0. So I'm going to take the sine of x and set it equal to 0. And I want to ask myself, where on the unit circle is the sign like the y value equal to 0? And that's in these these two places. Now on this interval, that means, notice that we're including the radian, that includes 0 pi and that includes 1 pi. Both have a sign value of 0 at those two locations. So I believe the solutions would be 0 pi or 0, but the same thing, and 1 pi. Now let's take the tangent of x minus 1 instead of equal to 0. I'm going to add 1 to the opposite side. Thinking of our unit circle, that would be right here, a reference angle of pi over 4. Pi over 4 would be the reference angle. Notice it's a positive 1. That means they have to have the same sign on the sine and cosine in order to achieve a positive 1. And in quadrants 1 and 3, we have the same sine tangent, both positive 1, because a positive radical 2 over 2 divided by a positive radical 2 over 2, and vice versa, a negative by negative, both gives us a 1. So I'm going to add pi over 4, and let's see, that's 1, 2, 3, 4, 5, and 5 pi over 4 to the list of solutions to this equation. Let's move it up and look. Alright, for number 27, I can see the given interval. I'm going to start by adding 3 to the opposite side. 4 cosine squared equals 3. Then I'm going to divide by 4. So I have cosine squared x equals 3/4. Then I'm going to take the square root, come back over here. I have the cosine of x, 2 answers equals plus or minus the square root of 3 over the square root of 4. Cosine of x equals plus or minus the square root of 3, and the square root of 4 is 2. So where can I find a cosine equivalent to radical 3 over 2? So 1, 2, 3. Now cosine is the first one. So radical 3 over 2. The reference angle is pi over 6. Now the cosines are going to be positive radical 3 over 2 in quadrants 1 and 4, and they're going to be negative. The cosines will be negative radical 3 over 2 in quadrants 2 and 3. So my 4 answers, because it's plus or minus, would be pi over, sorry, not pi, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are my 4 different solutions to number 27. We'll look at number 28. I can see that I'm able to factor out a cosine of x, and I'll be left with cosine squared x plus 1. And I see the given interval. Let's just make sure I did that correctly. Okay, so I'm going to set both of these quantities equal to 0. So either the left or the right equals 0. So where does the cosine of x equal 0? The cosine, or like the x value, equals 0 in both of these positions. So I believe in these two positions, again, where's the cosine x value equal to 0? Both right here and right here. So at 0 pi and at 1 pi. Now cosine squared x plus 1 equals 0. I move 1 to the opposite side. Makes it a negative 1. I take the square root. We can't take the square root of a negative, which means this does not provide us with a real answer. So where is the only place where the cosine, oh, you know what? I did the sine where the sine is equal to 0. Let me go back here. Where are the cosines equal to 0? So where is the x equal to 0? It's right here. 1 revolution, cosines are equal to 0 here at 0, 1 and 0, negative 1. So let me switch that back. The solutions here will be at pi over 2 and at 3 pi over 2. I was thinking in my mind sine when I chose those two locations. Again, why am I not considering